Good morning. Unless you're from another part of the world where it's no longer morning and has become afternoon, at least on the East Coast, it still is going to be morning time. I'm presenting this for Grace Engineered Products, and they are out of Davenport, Iowa. I am not in Davenport. I am in just outside of Nashville, Tennessee. I'm Charles Miller. I'm broadcasting the webinar today from my home in Lebanon, Tennessee. If you're familiar, you may not be familiar with Lebanon. Lebanon is the home of Cracker Barrel. Of course, Cracker Barrel has great food. It may not be so great for you. Well, they probably have food that's great for you, but that's not usually what I order when I go to Cracker Barrel. All right, let's go ahead and get started. We have a lot of material to cover in this 1 hour webinar. Electrical personal protective equipment, and it's based out of, all this information is based out of NFPA 70E, Standard for Electrical Safety in the Workplace. The objective today is to be able to determine if the tables in 70E can be used to determine the arc flash PPE category. I'll show you which tables we might be able to use, and I'll give you the information as far as, all right, this is, we can use it in accordance with this or not in accordance with that. We're going to learn an option for testing the absence of voltage while standing outside the enclosure. In order to work on equipment and work on electrical equipment without wearing arc-rated arc flash and shock PPE, the equipment has to be put into electrically safe work condition. We'll look at that definition in a few minutes, and we have to establish and verify the equipment is in an electrically safe work condition. There's another option instead of opening the equipment up being fully dressed. We'll talk about that in a little bit. Understand some of the NFPA general requirements for PPE. And as you can imagine, this is a 1 hour webinar, and there's a lot of information in NFPA 70E, so we're not going to be able to cover, of course, the whole thing in a 1 hour webinar. We'll cover as much as we can. Understand some of the, let's say, just cover that. Be able to select and use personal protective clothing and equipment, or otherwise known as PPE, that's appropriate for both arc flash and shock hazards. The purpose of 70E, NFPA 70E, is very similar to the purpose of the National Electrical Code. The National Electrical Code is a code that gives us rules and regulations for the installations of circuit conductors and equipment. 70E takes over after the installation. The purpose is to provide a practical, safe working area for employees relative to hazards that arise from using electricity. All right, so jumping right in, there are two types of boundaries for our electrical safety in the workplace. We have an arc flash boundary, and we have shock boundaries. There's one arc flash boundary. We have two shock boundaries. Several editions back, we had 3 shock boundaries. We used to have a prohibited approach boundary, but that was deleted. So now we have 2 shock boundaries, the restricted approach boundary and limited approach boundary. We're going to look at that in a few minutes. One of the things to notice about this drawing that I did is in this drawing, I have the arc flash boundary the furthest out from the 2 shock boundaries. That's not always the case. Arc flash boundary and shock boundaries are not dependent on each other. One doesn't have anything to do with the other. I've personally seen equipment labels, the arc flash warning labels, with the arc flash boundary as close as 3 inches. An arc flash boundary 3 inches from live energized circuit conductors and parts. And I've seen it as far away, a label that I have personally seen as far away as 21.5 feet. So they have nothing to do, the arc flash boundary has nothing to do with the shock boundaries. It's just, that's the way I made this drawing. Okay, so these are the two places in 70E where we're going to look for the requirements for both shock and arc flash. When an employee is working within the restricted approach boundary, the worker has to wear PPE in accordance with 130.4. The requirements for shock are in 130.4. When an employee is working within the arc flash boundary, he or she has to wear protective clothing and other PPE in accordance with 130.5. It also goes on to say all parts of the body inside the arc flash boundary have to be protected. We have certain restrictions before we cross into before we cross a boundary. We have certain restrictions, for example, crossing the arc flash boundary, we have to be wearing arc rated clothing and the proper arc rated equipment when we cross into the arc rated boundary. Before we cross into the restricted approach boundary, we have to be wearing protection PPE in accordance with the shock, the potential shock, the voltage level. We're going to look at that here as well. All right, so additional protective measures for shock. When the additional protective measures include the use of PPE, the following has to be determined. Now, this is, if you're looking at the slide, the lower left portion of the slide where it says 130.4b, this is where this requirement is located in NFPA 70E. All right, so what do we have to, when we're determining additional protective measures for shock, what do we have to know? Well, we have to know the voltage to which personnel will be exposed. We have to know the boundary requirements. Remember, I said the boundary requirements, we have two. We have the limited approach boundary, which is the furthest away. We have the restricted approach boundary, which is the closest of the two boundaries that we have now. Number three, we also have to know have to determine the personal and other protective equipment required by NFPA 70E to protect against the shock hazard. With shock, it's fairly basic. It's we're going to determine the voltage. We're going to look at a table, and we're going to quickly learn what is the restricted approach boundary and what is the limited approach boundary. Now, for shock, there's just a couple of things that we have to wear. We're going to either have to protect us or have to close off the shock hazard with the equipment itself. All right, the shock protection boundaries. I mentioned this. We have two. The limited is the furthest away. The restricted is the closest. We used to have a third boundary, two or three editions back, that was called the prohibited approach boundary. That boundary was eliminated because you had to do nothing different when you were about to cross the prohibited approach boundary that you already had in place for crossing the restricted approach boundary. There are certain things that you do or not do before crossing the limited approach boundary. There are certain things that are done or not done before crossing the restricted approach boundary. These are called triggers. For example, before crossing the restricted approach boundary, if you're taking tools with you, the tools have to be voltage rated. So there was no trigger in place for the prohibited approach boundary, so that boundary was eliminated. So the two boundaries shall be applicable where personnel are approaching exposed energized electrical conductors or circuit parts. Shock protection boundaries, where are they located? In table 130.4 D, A, and B. All right, so here's another drawing with just the two shock boundaries. In the center, that little red ball in the center represents live electrical conductors or circuit parts. The furthest boundary from that is called the limited approach boundary. The next boundary in, the closest boundary of the other boundary, is called restricted approach boundary. All right, so for alternating current systems, shock protection boundaries are dependent on nominal system voltage range. Well, how is it measured? Voltage is measured phase to phase. We have in this table, we have a footnote that references 120 volt circuits only. And we'll look at that in a minute. For direct current voltages, system shock protection boundaries are dependent on nominal potential difference for the voltages. All right, here's a little table that's based on the table 130.4 DA. All right, all dimensions are the distances from exposed energized electrical conductors or circuit parts to the employee. You'll see less than 50 volts, unless there's some other problem, other potential problem, less than 50 volts, this is AC, is going to be not harmful. So in other words, the limited approach boundary for movable and fixed, there's no distance specified. The restricted approach boundary for less than 50 volts, there is no distance specified. Then we get to 50 volts, the second row, 50 volts to 150 volts. There's a footnote that goes along with that row, and it says this includes circuits where the exposure does not exceed 120 volts nominal. Well, the footnote has to be in there because the title above column 1 says voltages measured phase to phase. Well, when we're measuring voltage in a 120 volt circuit, we're not measuring phase to phase, unless it is a certain type of 120 volt system that is that might be used in a recording or TV studio. Then it could be measured phase to phase, but normally no. 120 volts is measured phase to ground or phase to neutral. So we have a limited approach boundary. For that, we have 10 feet, 3.5 feet, which is the same as the row below that for up to 750 volts, but then going to all the way to the right, column 4, restricted approach boundary, it says for 120 volts, avoid contact. So as long as you don't touch it, then there is really no restricted approach boundary for 120 volts, except don't touch it, avoid contact. Now we get into above 151 volts to 750. This includes 208 volts, 230, 240, 277, 480 volts. The 277 would be voltage to ground, but the 480 volt, 460, 440. Then we have 2 limited approach boundaries. Again, the movable is where the person is not under the complete control, as in someone may be up in a bucket truck, or the lines are overhead lines that could be affected by the wind. Most of the time, unless what you're doing is utility type work, overhead lines, most of the time in industrial plants, your equipment is going to be fixed. So the limited approach boundary for both 120 volts all the way up to 750 volts is 3.5 feet. Then for 151 to 750, the restricted approach boundary is 1 foot. Where additional protective measures for arc flash include the use of PPE, the following shall be determined: appropriate safety-related work practices, the arc flash boundary, the PPE, personal protective equipment, that has to be used within the arc flash boundary. There's one arc flash boundary. There were 2 boundaries for shock. And for shock, we've got to determine, all right, if we're going to be crossing the restricted approach boundary, we're going to have to protect us. And what that is going to mean is rubber insulating gloves with leather protectors. That's going to take care of shock. Arc flash boundary involves more clothing and equipment. Here's the definition of the arc flash boundary. It says when, and this is in Article 100, and also it's covered again in 130.5E. When an arc flash hazard exists, an approach limit at a distance from the arc source at which incident energy equals 1.2 calories per square centimeter or 5 joules per square centimeter. All right, so I teach a lot of seminars. I'm hired out and I do custom seminars, and typically I'll do any length as far as the client wants. Usually, most often what I do is a one-day seminar, and quite often I'll follow that up with a half day of hands-on training. In the class at some point or other, I usually talk about the arc flash. Well, of course, I'm going to talk about the arc flash boundary. And I'll open a disconnect. I may bring a disconnect with me, or even like this piece of equipment behind me. This disconnect that I have, the safe test point for Grace installed, and we'll look at that, talk about that in a few minutes. But if I have a piece of equipment open, and the arc flash boundary was calculated at being 3 feet. The further away I go, if I go 4, 5, 6, 7 feet, the further away I go, do you think the arc flash or the incident energy goes up, or do you think it goes down the further away I get? Exactly, it does go down. So if saying the arc flash, saying it at 3 feet, it is 5 calories at 3 feet. So you keep going back further. And then when that incident energy drops to a level of 1.2 calories per square centimeter, that is the arc flash boundary. And that Dr. Stoll had did the research and calculations on this, and 1.2 calories is the amount of energy, amount of heat on skin that will give a first-degree burn. Sometimes it's called the onset of a second-degree burn. It's not a second-degree burn yet, but it's as close as you can get to a second degree. And so going over 1.2 calories per square centimeter becomes a second-degree burn. That's why the arc flash boundary is based on getting a first-degree burn if you're standing right on the boundary. In fact, it's a lot of industries, a lot of plants, a lot of people need to understand that if the electricians, if the maintenance men have blocked off an area in front of a electrical panel or industrial control panel, a piece of equipment, and they are working on that piece of equipment energized, or they have it open and it is energized, maybe they're doing testing, troubleshooting, voltage measuring, and if it is blocked off, if somebody comes up and leans over that boundary, and if that boundary was installed at exactly the arc flash boundary, then even if they're not leaning over, even if they're just exactly at the arc flash boundary, and there's an incident and there's an accident or an electrical explosion, then that person could receive a really bad first degree burn. Have you ever had a bad sunburn? And of course, most of us have. And so this 1.2 calories per square centimeter is, I would say, worse than even a really bad sunburn that you or I have had. I also talk about in class that a good example of showing you, kind of giving you an idea of a first degree or this 1.2 calories is if you had a lighter and you held your finger in the blue flame for 1 second, that would be an approximate area of 1 square centimeter, and it would be 1 calorie per square centimeter at 1 second in the blue flame. Is that going to hurt? Well, yes. So the 1.2 would be all of your skin being hit by the blue flame or blue fire for a fraction longer than 1 second. And absolutely, that's going to hurt. It is curable. your skin will survive from that, and it will heal itself. Anything over that becomes a second or third degree burn. One of the following methods have to be used for selecting arc flash PPE. There's two ways for knowing what PPE to use. First of all, the incident energy analysis method in accordance with 130.5G. This is where a company may come into an industrial plant and do all the calculations necessary to determine determine what needs to go on the label for each piece of equipment. Now, I did say it may be a company coming in. There are plenty of companies out there that have engineers on staff in the company that they do this labeling themselves, and that's fine. There's no problem with that. 70E says that all the equipment that's liable to be adjusted, serviced, maintained while it's energized have to be labeled with the information. And so this is one option where you have arc flash labels on equipment that gives us certain amount of information. It gives us the arc flash boundary. It may give us the category. It may give us the incident energy at 18 inches. And we have information that we get off of that. There's another method, and it's using the tables in 70E. It is the arc flash PPE category method in accordance with 130.7C15. If you're somewhat familiar with arc flash, with 70E, with personal protective equipment, arc rating, there are 4 categories. Now, be careful that we're not talking about test instruments at this point, but test instruments also have 4 categories. These categories, and it's abbreviated CAT. These categories have nothing to do with each other. So category 2 and for arc flash does not mean you need a test equipment or voltage detector that is at least category 2 rated. They have nothing to do with each other. They just happen to be called categories. They abbreviate CAT. There are 4 of them. There are 4 categories. We'll look at some of the ratings for the 4 categories for PPE. On your label, in fact, it says either can be done, but not both. Methods shall be permitted to be used on the same piece of equipment. Here's a label that I took a picture of a couple of years ago. This label was on a piece of 4160 volt equipment, 4,160 volts, as you see on the label. This label, it was done a while. It was done quite a while back. Of course, even when I took the picture, it was out of date, right? If you're familiar with, we know that it's required to review the label every 5 years, and this label has 2 things on it. It has the arc flash boundary, which is required to be there, but it has incident energy at the working distance, and it also has the category. This one is showing category 3. We're allowed to put one or the other on there, but not both. It wasn't specifically stated several editions back, but and I know a lot of companies did that, but let's look at the potential problem if it is done. All right, in this case, it does show 8.1 calories per square centimeter at 36 inches. This was a draw out type circuit breaker, a rack in, rack out type circuit breaker. So typically the working distance are anywhere from 24 to 36 inches or so typically. This shows 8.1 calories. Well, a category 2 has to be at least 8 calories. So anything over that would jump to a category of 3. Now, if it didn't have category 3 on the label, then whoever's working in front of this equipment, may just even racking in, racking out the breaker, all they would have had to wear was arc rated clothing, hard hat, face shield, everything rated up to 8.1 calories. 8.1 or above. Well, because it went above 8, then the category that was put on there was 3. So in this particular and the plant, this where I took this picture, when they were racking a breaker in and out, they had to wear a full-blown arc flash suit. Well, it's they didn't have a 3, they had a category 4, and in this particular case, it wasn't bad, but because where this was located was inside an electrical room that was heated and cooled, air conditioned very well. And so it wasn't a big deal for putting on an arc flash suit with a category instead of just arc rated shirt and pants and hard hat and face shield that had at least 8.1 calories. So that wasn't a big deal. But if you're in other areas, about 3 or 4 weeks ago, I was in Laurel, Mississippi. Laurel, Mississippi gets rather hot. So it's something like this could be critical if someone's working outside. Now, are they well protected? Absolutely. Would they be protected if everything was calculated correctly at 8.1? Yes. And where I was working a couple of weeks ago, it was even hotter than Laurel, Mississippi. Alternative, instead of performing a detailed incident energy analysis to determine the incident energy at the working distance, it's permitted to use table 130.5C to determine if PPE is necessary. And if so, then we're going to go to these other tables. Let's go ahead and look at them. Instead of performing incident energy analysis, it is permissible to use the tables in 70E if meeting the parameters. Now, these tables have parameters. We have to know the maximum available fault current, the maximum fault clearing times, the minimum working distance for various equipment. So here's the table, 130.7C15A. The parameters are in this table. The parameters for this one, a maximum of 25,000 available fault current amps, the maximum of clearing time of 0.03 second or 2 cycles, the fault clearing time, and the maximum working distance of 18 inches. Now, normally 18 inches is for fixed equipment. 18 inches is typically the working distance, and that's usually figured from the live energized parts to your body when you're holding something like test leads for test instruments for voltage detectors. An incident energy analysis shall be required in accordance with 130. Shall be required in accordance with 130.5 for the following. What this is meaning is that you have to do an incident energy analysis if the task is not listed in this table, if the power systems have greater than estimated maximum available fault current, if the power systems have longer than the fault clearing times that are listed in the parameters, or if you're going to be working the working distance, if it's going to be considered less than 18 inches. All right, so we're going to look at table 130.5C to see if arc flash PPE is required. Then we're going to go to these other tables, and then if it is required and if we're able to do it, then we're going to look at the PPE category table in order to select our arc rated PPE. So here's a problem, here's a task. Perform voltage testing on a 200 amp, 3-phase, 480 Y system, 277 volt panel board. Now, if you notice, this panel board is Square M. Now, you're probably familiar with Square D, and they are a really fine brand of equipment, but this is Square M. It is the Miller brand equipment. It is the Cadillac of equipment. Besides teaching and writing, I also do my own illustrations. So, okay, so I'm giving you a task. You're going to perform voltage testing. That means the panel board is going to be energized. And I'm giving you the available fault current is 21.5 KA, 21,500 amps. The clearing time is 0.03 second. And then I have a question, is PPE required? Well, we're going to look at the table, But before going to the table, you're going to be testing voltage on a live panel board. What do you think? Do you think you're going to need to wear arc-rated PPE when you're doing this testing? Well, yes, of course you are. Now, we'll look at this. We'll see this in the table. 130.5C says for AC systems, work on energized electrical conductors and circuit parts, comma, including voltage testing. Equipment conditions, it doesn't matter what the equipment conditions are. It says the likelihood of occurrence is yes, meaning arc-rated PPE is required. If it says yes, if no, then arc-rated PPE is not going to be required. All right, so yes, of course, there is a likelihood of occurrence. Well, you knew this, we knew this before looking at the table, but this just confirms it absolutely, because there's some tasks in here that maybe you're not sure of if this would need arc-rated PPE or not, and then we can it is good to know this where this table is and to know what's in this table. Next, we're going to check to see if the equipment is listed in table 130.7C15A. If it's listed, we're going to check the parameters. And so this is 480 volt equipment, phase to phase, so it's the second row down. Panel boards or other equipment rated greater than 240 up to 600 volts. So that's the row we're looking at. Parameters, maximum of 25,000. I gave you 21,500 amps. Check. That's good. Clearing time 0.3 second, which is the maximum clearing time. And I also gave you the working distance of 18 inches. Therefore, we can use this table. Now we're going to find the arc flash PPE category. Second row down, arc flash PPE category is 2. Well, what is the arc flash boundary? That's in the table also. The arc flash boundary is 3 feet. All right, so I know plenty of contractors out there. I know there are plenty of companies that are trying to do the right thing. Maybe they're hired to go check, do some voltage testing or look for problems in a panel board in an office building. And so they've got to open the panel board, take the cover off while everything is energized. If they're looking for and even testing voltage and amperage. And so they go into this office building, they find this panel board or multiple panel boards, and before taking the cover off, they know that they're going to do voltage testing, so they know they have to wear PPE. They look on the panel board, there is no label. The owners of the building have not had the panel boards labeled. And so then what's their choice? They go to this table. Well, they go to 70E. They look at this and they go, well, wait a minute, I don't know the maximum available fault current. I don't know the clearing time, because in order to know this information, you would have to do a system study. A system study is just a couple of clicks short of being able to print off a full arc flash label. And I know companies that are using these tables without knowing the parameters. I can't say that is absolutely not correct to do. I know companies that are doing that, and their opinion is, at least if they're going by this, they're wearing something, they're doing whatever they can, because they're not going to be able to do a system study on a building that they're just going to go into and do a service call and just some voltage measuring, current measuring. And so I know the tables are being used, although that companies do not know if the parameters are in place or not. We finally look at table 130.5, 130.7 C15C for what we would have to wear. This is, remember on the previous slide, it showed a category 2. And so what category 2 has to be at least 8 calories per square centimeter. What can they wear? Arc-rated long sleeve shirt and pants, or arc-rated coveralls. A lot of industries and plants have, or some industries and plants have daily wear arc-rated clothing. And arc-rated clothing has gotten so much better over the years. I've got a shirt in the closet that's is one of the first arc-rated shirts, and it's 8.7, which was pretty high, really good at the time. But wearing that shirt is like wearing starched burlap. It is not comfortable. Clothing has gotten so much better over the years. Lightweight, they have long sleeve shirts that's just like wearing a cotton long sleeve shirt. It's very comfortable. What else? Arc-rated flash suit hood, or arc-rated face shield, and arc-rated balaclava, arc-rated jacket, parka, rainwear, or hard hat liner as needed. There's going to be a change to this last row in the 2021 edition, which will come out probably mid to late September this year. And there's going to be a footnote that goes along with that, and it's even going to include high-vis vest, high-vis clothing, high visibility clothing. And what the footnote is going to mention is your outerwear has to be arc-rated, but it does not have to be up to the level of the incident energy of where you're working. This is important, and this is until last year or a couple of years ago, I always thought that the outer layer had to also be equal to or above the incident energy of your equipment where you're working, and it has to be arc rated, but it doesn't have to be. So say if there's an arc rating of 6 calories on the label, on the equipment label, on the label on the equipment, 6 calories. Your clothing, maybe you're wearing a daily wear shirt that is 8.7 and your pants are 12, and you have to wear a high-vis vest because of where you're working. Well, the vest doesn't have to be 6 calories. It doesn't have to be 8.7. It has to be arc rated, but it's not going to have to be that high of an arc rating. All right, what else do we wear? Hard hat. Safety glasses or safety goggles have to be worn underneath even the face shields, regardless. I've got a slide coming up on that. Hearing protection. And some of smart Alex out there probably said, what? And I know some of the people watching, so believe me, I think they just did that. Heavy-duty leather gloves. There's a footnote with that heavy-duty leather gloves. In fact, once we get to category 3 and category 4, it will say arc-rated gloves. Well, there's a footnote that goes with that, footnote D. And footnote D says, if rubber insulating gloves with leather protectors are used, additional leather or arc-rated gloves are not required. What this means, if you are wearing rubber gloves with leather protectors, that takes the place of having to have heavy-duty leather gloves. If you're wearing rubber gloves with leather protectors, that takes the place of having to wear arc-rated gloves in accordance with that table. So the combination of rubber insulating gloves with leather protectors satisfies the arc flash protection requirement. Now, Terry, a friend of mine in this picture, he has on an Oberon category 4 arc flash suit. Category 4, in fact, I've got the hood behind me here, and their face shields are amazing. Their face shields are called True Color Gray. And you're probably thinking that, wow, you sell a lot of stuff. I don't actually sell anything. I'm an electrician by trade that grew up and was either taught the wrong way of doing things or wasn't taught the right way of doing things. But I see equipment that's out there. I see meters. I see things that are out there that I think are great, and I absolutely want to let people know about them. This shield. True Color Gray shield. It's not very dark whatsoever. Terry's wearing gloves that are that are class 2 gloves rated for 17,000 volts. Now, there's no requirement for having to wear, for a higher category, having to wear a higher rated voltage glove. If he was working or I was working in an area that would require a category 4, maybe something, maybe it's 30 calories, and so I put on an arc flash suit good for 40. If it was 480 volts, I could wear the gloves rated for either 500 or 1,000. I wouldn't have to jump the glove up to be a certain heavier rubber or heavier leather glove. Electrically safe work condition is a defined term. It is a state in which electrical conductors and circuit parts have been disconnected from energized parts. They've been locked and tagged in accordance with established standards. They've been tested to verify the absence of voltage and, if necessary, temporarily grounded for personnel protection. There are 8 steps in establishing and verifying that equipment is in an electrically safe work condition. Now, we don't have time to look at all these. Let's look at number 7, testing for voltage. Number 7 says use an adequately rated portable test instrument to test each phase conductor or circuit part to verify it's de-energized. Test each phase conductor how? Phase to phase and phase to ground. This is also, some people refer to this as live dead live testing. Before the test and after the test, make sure that the test instrument, voltage detector, is working properly through verification on any known voltage source. All right, so what is this? In testing for the absence of voltage, we have to test our tester, test for the absence of voltage, and test our tester again. Fluke makes what they call a proving unit. This is great. 4 AA batteries in this, and it's got an AC or DC switch. It gives roughly around 240 volts. So if you turn off all the power in a certain area, you can use any voltage to test your meter. You could use a 9-volt battery, a AA battery. It doesn't matter. And most meters, though, not all, but most meters, if you're checking DC, you have to change the dial. Check AC, you change it back to the AC setting. Checking DC again, you change it back. I'm a bit cautious or hesitant when I'm talking to people and say, oh yeah, this is fine. It is permitted, but there's a potential for human error there. Putting the meter in the wrong setting. But before the test, will you make sure the meter's working? Then you're testing for the absence of voltage. How do we do it? Phase to phase and phase to ground. And then what? Well, after the test, we also make sure the meter is working properly on any known voltage source. It doesn't have to be the same voltage you're working with. This proving unit from Fluke is a great instrument. I don't have one with me, or it's in the garage, but it is a great instrument to give you voltage at your source, at hand. You can just, it's got a nice magnet. You just put it right where you're working. Voltage presence indicator lights typically do not meet the requirement of 110.57, exception number 1. Exception number 1 is an absence of voltage tester. Now, Grace Engineered Products, you're probably familiar with their products. We've seen these types of test lights. They're called permanent electrical safety devices, or PESDs. We've seen these in industries around the country, industrial plants. They're wonderful. Electrician or maintenance person walks by and they see the 3 lights up there going, that's good. Power's there, power's there, power's. It's great. It's a great indication, a voltage indicator. But when you turn off a piece of equipment, those lights go out, that is not enough. When we're going to get into a piece of equipment, we have to go some additional steps other than just plain lockout tagout. But we have to go through these additional steps for testing for the absence of voltage. But Grace has another option, and this is wonderful. I think this is better than sliced bread. I don't know. This is a great option. Another option is to install a safe test point to test for the absence of voltage while standing outside the electrical equipment before you even open the equipment up. What this allows you to do is, while you're standing outside, okay, you've turned off the power, you've gone through the steps, you get to step number 7, and you're testing for the absence of voltage. You test your tester, then standing outside the equipment, you're testing phase to phase and phase to ground of all the circuit parts. Then you test your tester again, and at that point, you have established and verified the equipment is in an electrically safe work condition. You can open the equipment up without wearing shock or arc-rated PPE. This is the box I have behind me. It's got the lights on it. I've got a VFD installed. I've got in fact, it is the smallest 3-phase 230-volt motor I have ever seen inside this box. It is 1/125th of a horsepower. 1/125th of a horsepower. It's incredibly small, but it's Grace provided me with this safe test point combination. It's got the lights on it. It has a safe, it's got the voltage indicator lights on it and the safe test point on it, where when I de-energize this box, standing on the outside of this box, I can test for the absence of voltage, phase to phase and phase to ground. Back in Laurel, Mississippi, about a month ago, I did training, and this is part of the hands-on training. They have this combination unit on a piece of equipment that they have in a water well station, pulling water off for the city. And this is, as far as we were doing more than just testing for the absence of voltage. That's why I'm suited up. The guy on the right with the left picture is suited up, because I had them go into this equipment doing voltage testing and current measuring, and having suited up and knowing what all to wear. The picture on the right, the gentleman not wearing any PPE, is on the outside of the equipment, testing for, first of all, testing the meter, then testing for the absence of voltage, then testing the meter again. And then at that point, he can open the equipment up without wearing shock or arc-rated PPE. 70E employees, okay, this is talking about the PPE. Employees exposed to electrical hazards when the risk associated with that hazard is not adequately reduced by applicable electrical installation requirements have to be provided with and have to use protective equipment that is designed and constructed for the specific parts of the body to be protected and for the work to be performed. Shock protection. Employees have to wear rubber insulating gloves with leather protectors where there's a danger of hand injury from electric shock due to contact with energized electrical conductors or circuit parts. Well, the rubber insulating gloves have to be rated for the voltage to which the glove is going to be exposed. Talked about this a while ago. There, as far as I mentioned, one class 2 glove that Terry was wearing, but it goes anywhere from 500 volt rated glove up to 36,000 volts for the gloves. What are we supposed to do? We're supposed to inspect for damage before each time using the gloves. And so what do we look for? Cracking caused by prolonged folding or compressing, a snag in the lower picture. Now it's showing the black on the outside and red on the inside. Not all gloves have the 2 color. Some gloves, or a lot of gloves, are just solid color, whether black or blue or red, all the way through. Then also we're going to look for things like swelling caused by oils and petroleum compounds. And what else do? We have to give the gloves an air test along with the inspection. We roll it up, we look at the glove and just get a good idea. And I know some people will hold it up to their ears to hear, see if they hear the air leaking out. With me, my hearing is not that good. So, and then also, if someone already has in hearing protection and maybe in a noisy electrical room, how good is that going to be? How are you going to be able to, how well are you going to be able to hear that? But mainly just look over the glove, make sure it's in good shape, make sure there's nothing wrong. Employees have to wear arc-rated clothing whenever there's a possible exposure to an electric arc flash above the threshold incident energy level of a second degree burn, and anything above 1.2 calories per square centimeter. Mentioned that number a while ago. That is the arc flash boundary. Anything above that becomes a second degree burn, and then on up to even a third degree burn above that. This was a shirt I was talking. Well, no, this is a very comfortable shirt. It's not the one that feels like starched burlap. The arc rating on this shirt, now it has ATPV, it has arc rating on it, and on the back collar it also has FR. If you're familiar with calling them FR clothing, fire resistant clothing, with 70E, that was eliminated a couple, 2 or 3 editions back, the term FR. It always had to be arc rated, but there was a term that was used in there for FR, and some clothing manufacturers or laundry services may refer to it still as FR, and that's okay. But it also always has to have an arc rating, either ATPV, arc thermal performance, or energy of break open threshold, E sub BT. This shirt is very soft, very comfortable at 8.4. It's like a heavy duty denim shirt. They have shirts now that are even so much lighter than that have a higher arc rating on it than that one as well. Category 2, a while ago, that's for voltage testing. We had to be wearing a 480 volt panel. We had to be wearing category 2. So this one, on the left is the arc flash, the full-blown arc flash suit hood or beekeeper's type hood. Has a light on the front. In fact, this hood even has a fan to bring in fresh air. It helps help you cool on the inside. With category 2, you can either wear arc-rated flash suit hood or arc-rated face shield and arc-rated balaclava. Instead of using an arc-rated flash suit hood, it is permissible to use an arc-rated face shield with an arc-rated balaclava in a category 2 location. Minimum arc rating clothing in a category 2 looked at a while ago was 8 calories per square centimeter. This the young man in the picture is my stepson. He was modeling the arc-rated balaclava. This arc-rated balaclava is rated 14 calories. An arc-rated balaclava. So your question is, well, if I just wear a hard hat and face shield, is that okay? Do I have to wear the arc-rated balaclava? Well, here's your answer. If you were thinking that, an arc-rated balaclava has to be used with an arc-rated face shield when the back of your head is within the arc flash boundary. All right, so with this label, in fact, you see this label, this is a label that I drew up, and if you may not be familiar with some of my drawings and illustrations and some of the books that I've written and published, and this arc flash boundary on my label is 4 feet 5 inches. Do you think the back of your head is going to be within the arc flash boundary, being that it's 4 feet 5 inches? Well, yes, of course it is. I mentioned earlier that I've seen labels as close as 3 inches, 3, 6, 7, 8, 1 foot, 12, 13 inches. If the back of your head is not within the arc flash boundary, you don't have to wear an arc-rated balaclava. If it is, yes, absolutely, you're required to wear the arc-rated balaclava. The date on this, I do little things in my drawings, like the date on that label, 3/26/2018. Now, in my drawings, on labels, I'm going to have them within 5 years of when I'm actually doing the training, like now. So it has to be within the last 5 years. That's required to be updated, reviewed, to look at and possibly change it. The 2018 isn't that important. 3/26 is. It's March 26th, and that's my wife's birthday. Not that I've ever forgotten her birthday or our anniversary yet, but if I ever do, with my drawings and illustrations and PowerPoints and books, I can figure it out pretty quick if I ever forget. Again, I've not forgotten her birthday or our anniversary yet. Eye protection. Safety glasses or safety goggles have to always be worn under the face shields or hoods. The shield has to go through the same type of measurement or test to make sure it's good for stopping penetration of objects, just like safety glasses have to. But we still have to wear safety glasses or safety goggles underneath the face shields anyway. Well, this is not a big deal. Most industrial plants, the people have to wear the safety glasses all the time anyway, so it's not a big deal for this one. Hearing protection. Employees have to wear hearing protection whenever working within the arc flash boundary. If the arc flash boundary is 3 inches, no, you don't have to wear hearing protection. Well, maybe if you're in a plant that requires you to wear hearing protection in the plant, well, yes, you do, but not because of 70E, but because of your own safety rules. If 4 feet 5 inches, if you're within the arc flash boundary, and you would be within 4 feet 5 inches, you have to wear hearing protection. And I know companies that have it in their policy that whenever they're working in front of live equipment for any reason, that they're going to wear hearing protection anyway. And that's a good rule. All right, let's see. Any questions? We'll take a breath now. That's quite a bit to cover in a very short period of time, but I wanted to give you as much information as I could. 70E, of course, is a huge document. It covers lots of information. All right, so I know so far as we're not going to be able to get to all these questions, and my contact information is up here. Feel free to write me. Feel free to ask me your question. Make sure you go ahead, if you're sending me an email, put on there your phone number as well. So sometimes it's easier for me to pick up the phone and call you than take a whole lot of time, especially if I may not have enough information to be able to send you the email back. Put your number on there, and I'll try to give you a call. I know there's a lot more questions up there, but again, feel free to send me these questions, and I'll be happy to help you answer these. And thank you for attending.
Bureau of Labor Statistics and OSHA reports that maintenance work involving the lockout-tagout task as one of the top 5 contributors for workplace electrical accidents. Most of these accidents occur while performing a mechanical or electrical lockout-tagout to verify the de-energized condition of the equipment, or when creating an electrically safe work condition per NFPA 70E. Studies and research also indicate that failure to stop the equipment, failure to disconnect from the power source, failure to dissipate residual or stored energy, and creating an electrically safe work condition is especially hazardous due to the task frequency, as well as being the top 3 causes for lockout-tagout preventable injuries. Permanent Electrical Safety Devices, or PESDs, combine the electrical safety by design principles outlined in the risk control hierarchy and are applied to either eliminate the risk or reduce the risk to a minimum acceptable level while performing lockout-tagout tasks. PESDs are electrical components that are permanently installed into electrical systems by hardwiring them directly to the source of voltage. These devices enable electricians or maintenance workers to validate the presence or absence of voltage from outside the electrical cabinet door without ever being exposed to hazardous energy inside the door. PESDs, combined with risk-certified procedures and drafted by a certified safety professional, enable a safer and more productive lockout-tagout. Grace's PESDs consist of voltage indicators, voltage portals, and combination units of the two. Our voltage indicators visually represent the presence of voltage with flashing or non-flashing redundant LED lights. In addition, these indicators also show the lost phase, stuck blade condition, and dissipated energy of the connected source. The voltage portals offer the maintenance personnel with a no-touch voltage detection using an NCVD pen on the outside of a grounded electrical cabinet. On the other hand, a safe test point portal with 102 kiloohms high impedance protected circuit offers the qualified person to perform the absence of voltage test from outside the cabinet without opening the door. These high impedance protected Cat 3 and Cat 4 rated and UL listed PESDs provide the means to safely verify presence or absence of voltage, either phase to phase or phase to ground in both AC and DC systems up to 1000 volts, without exposing the worker to arc flash or shock hazards. When properly incorporated into a facility's electrical and mechanical lockout-tagout procedure, PESDs enhance the compliance with NFPA 70E, CSA Z462, and OSHA energy isolation principles. All of our PESDs can be combined in several available standard and custom configurations for either door or flange mount installations, as well as with procedure labels to further reduce the task risks to bare minimal levels. Voltage Test Station is another form of PESD that combines a voltage indicator and safe test points in UL-recognized lockable housings with Type 4, 4X, and 12 ratings. Other PESD product variations include flex mount voltage indicators that can mount onto any electrical enclosure with 3/4 inch or M20 conduit knockout, a fiber optic voltage indicator for use in dead front bus panels with no voltage to the door, and a medium voltage indicator that can bolt directly to the bus bars from 2 kV through 43 kV systems. No matter how simple or complex your lockout-tagout procedure is, we have a PESD that answers your unique need. Over a decade, we have earned the trust of many Fortune 500 companies that have installed hundreds of thousands of these PESDs into their equipment as part of their electrical safety programs, and are a testament to our product reliability and effectivity. Visit www.pesd.com to understand the benefits beyond compliance.